Let's remember what we've talked about so far. We've talked about an array, which is an arrangement of horizontal rows and vertical columns. An array must be made up of any number of objects that can be put into equal rows and columns. Our I can statement is I can solve real-world problems by using arrays. Our key vocabulary that we need to know for today is repeated addition, which is adding the same number or addend over and over. So today we will have a scenario paper where we will think about the number of ants, so 4, 5, 6, all the way up to 16. And we will create an array for all of these ants. Miss Elliott is not going to do all of these for you. I'm only going to do a couple of them, and then you guys are going to do the rest. So looking at my sheet, I see that the queen, number of ants that the queen wants to arrange first, is 4. So I see that you can do 2 rows, 1 row, 2 rows, and then have 2 columns. So it would look like this. And my equation would be 2 plus 2. My equation would be 2 plus 2 is equal to 4. But I also could make 1 row of 4. 1, 2, 3, 4. So it could also be looking like this. 1, 2, 3, 4. And that would, my repeated addition would be 1 plus 1 plus 1 plus 1 is equal to 4. So now I need 5. I already have 4. 1, 2, 3, 4 in 1 row. I could add 1 more penny to make, oops, you can't see that. Oops. 1 more penny, and that could equal 5. 1, 2, 3, 4, 5. So my array would look like this. 1, 2, 3, 4, 5. And my repeated addition would be 1 plus 1 plus 1 plus 1 plus 1 is equal to 5. I could not do 2 rows, of 2 rows, because that is not equal. So the only way I could do an array to have equal, which would be equal horizontal rows and columns, would be this way. So it'd be 1 row with 5 columns. My next one would be 6. So I could add 1 more penny to my 5, and I could do 1. So it would look like this. 1, 2, 3, 4, 5, 6. So it could be, my equation could be 1 plus 1 plus 1 plus 1 plus 1 plus 1 is equal to 6. Or I could have 2 rows of 1 row, 2 rows, and then add, so it'll be 2, 4, and then flip them over. It could be 6. So it could look like this. 1, 2, 3, 4, 5, 6, and that'd be 2 rows of 3. So it would be 3 plus 3 is equal to 6. If I add 1 more penny, it would get me 7. Oops, you can't see that. There we go. But that's not equal. So the only way it would be equal is if I moved those to be one long line of 7. And you can't see all my pennies, so I'm going to make them squish them in a little bit more. 1, 2, 3, 4, 5, 6, 7. So my array would look like this. 1, 2, 3, 4, 5, 6, 7. So it'd be 1 plus 1 plus 1 plus 1 plus 1 plus 1, 3, 4, 5, 6 plus 1 is equal to 7. My repeated addition. Now if I wanted to do 12, so I already have 7, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So because I know 12 is an even number, I can have 2 rows. So here's 1 row, and here's 2 rows. And I can count by 2s. 4, 6, 8, 10, and, oops, 12. So I would have 2 rows of 1, 2, 3, 4, 5, 6, and 6 columns. So my equation could be 6 plus 6 is equal to 12. And my drawing looks like this. 1, 2, 3, 4, 5, 6. There's 1 row. And there's my second row. I could also have 1 long line of 12, but I'm not going to do that. I'm going to try it with 3 rows. So here's 1 row, here's 1 row, 2 rows, 3 rows, right? And I'm going to keep adding 3 to each. And that would leave me with 3 rows of 1, 2, 3, 4. So that would be 1, 2, and 3. Here's my 3 rows. And my 4 columns. So it could be 3 plus 3 plus 3 plus 3 is equal to 12. So now it's your turn. Let's look at the you-do for today. So you will finish filling out the chart that I have created during the mini lesson. So you can either do this by printing out this chart and filling it in, or you can draw the chart on a piece of paper and fill in the rest. We can't wait to see your work, and we will see you soon.